In this video, we are going to explore how scale drawings can be used effectively to determine the resultant force acting on an object. Imagine a scenario in which a man riding a bicycle is pedaling with a force of 4 newtons directed towards the north. Simultaneously, a strong breeze is exerting a force of 3 newtons pushing him towards the east. We can illustrate this scenario visually by using a grid where the cyclist is represented as an orange, and the forces acting on him are drawn using arrows. The force created by pedaling northward is drawn as a 4-centimeter arrow pointing upwards, and the force of the wind is shown as a 3-centimeter arrow pointing to the right. We are using a scale where each centimeter represents 1 newton, which makes our drawing to scale and suitable for precise analysis. With this scale diagram in place, we can find both the size and direction of the resultant force by arranging the 2 force vectors tip to tail. This involves moving the eastward arrow so that its tail is aligned with the tip of the northward arrow. When this is done, the resultant force can be found by drawing a straight line from the starting point of the first vector to the end point of the second. Because our diagram is created to scale, we can measure the length of the resultant vector directly using a ruler. In this case, the measured length is 5 centimeters, and since 1 centimeter represents 1 newton, the magnitude of the resultant force is 5 newtons. To determine the direction of this resultant force, we use a protractor to measure the angle it makes with the original northward direction. This angle is approximately 37 degrees. Therefore, we can describe the resultant force as 5 newtons acting at a bearing of 37 degrees from north. In some situations, the forces acting on an object may cancel each other out completely, which would mean that the object is in a state of equilibrium. For example, if a particle has 3 different forces acting on it, we can use the same tip-to-tail vector arrangement method to analyze the situation. If the 3 vectors form a closed triangle where all arrows connect perfectly with no gaps, it means the forces balance out exactly, and the resultant force is 0. This is a clear indication that the object will not move and is in equilibrium. It is important to note that the order in which we place the vectors tip to tail does not affect the final outcome. As long as they are arranged properly in a tip-to-tail manner, the result will be the same. We could rearrange them in any other order and still observe a closed triangle, which confirms that the resultant force is still 0. Now, let us move on to the final concept of this lesson, which is vector resolution. Resolving a vector means breaking it down into 2 simpler forces, one acting horizontally and the other acting vertically. This is essentially the reverse of what we have been doing. Let us consider a toy car being pushed up a ramp with a force of 50 newtons. If we decide on a scale where 10 newtons is represented by 1 centimeter, we can draw the original force as a 5-centimeter line angled along the direction of the ramp. To resolve this force, we draw a horizontal line from the bottom of the force line and a vertical line from the top, creating a right-angled triangle. Each of these lines represents one component of the original force. We then place arrows on each component line to indicate their respective directions. Using a ruler, we measure the horizontal line to be 4 centimeters and the vertical line to be 3 centimeters. With our chosen scale, this means that the horizontal component is 40 newtons to the right and the vertical component is 30 newtons upward. We have now effectively broken down or resolved the original 50-newton force into its 2 perpendicular components, making it easier to analyze in various calculations or physical interpretations. That wraps up everything we wanted to explain in this video. We hope this breakdown using visual and practical methods helped you understand how to use scale diagrams to calculate resultant forces and resolve vectors into components. If you found this video useful and informative, please consider giving it a like and subscribing to our channel. We truly appreciate your support and hope to see you again in one of our future videos very soon.